Let's begin with the history of mathematics. In this topic, we are going to know where did the history of mathematics came from. So, it is vital to study the history of mathematics for us to know how it's developed in many years. The role mathematics has played for centuries in Western culture and to recognize achievements in other cultures. And this mathematics history will help to counteract the fear and hatred of mathematics that many general education or liberal arts students express. And also, it helps students who love mathematics will feel even more closely connected to culture and society after studying the central role played by mathematics in both. Studying mathematics history will help the students better communicate mathematical ideas to those whose mathematical understanding is not as great as theirs.
We are the group 1.
Greetings and salutations to everyone. Hope you have a nice day today. And anyway, today let me and my group mates share to you about the beginning and the history of mathematics, which includes the Babylonian numeral system. To discuss these topics, I'm going to introduce myself first. I am Charlotte Alforque from Section ADM 1B, and my co-reporters also we have Miss Chamiros Alotaya and we have Miss Joella Bagay, and we are the Group 1.
Mathematics in the modern world roots in ancient Mesopotamia, Egypt, and Babylonia. Then it was developed in Greece, China, and in India. So the ancient Greece mathematics with some influence of Hindu mathematics spread to the neighboring countries in the Middle East. Ancient mathematics in 3000 BCA, the first developer of numerical system that based on the power of 10 is Egyptian called hieroglyphic numerals. What is mathematics? So, mathematics is known as the queen of sciences that fill every area of human lives and known as the human language. And also, it comes from the ancient Greek mathema, meaning that which is learned. What one gets to know hence also study and science. The Babylonian numeral system, it is rooted from Sumerians. It is an old number system in 19,000 BC to 18,000 BC. They uses based on the power of 60 or they called sexagesimal system. And they use stylus. They dug in it in clay tablet and used in astronomy and aided them to create abacus. This is the Babylonian numeral clay tablet, and this tablet was 3,700 years old, and it is the world's oldest and most accurate trigonometric table, and it is used to calculate and construct palaces and temples and build canals, and it was created by the Babylonian surveyor. And we have here the stylus, and it was 3,000 years. A stylus is a writing tool used by Babylonians to write cuneiform symbols as well as their numeral system. As you can see in the picture, there are examples of two symbols of Babylonian numeral system. The first symbol is equivalent to 1 and the next symbol to it is equivalent to 10.
Let's have fun with this example. Example number 1. We have here a Babylonian numeral symbol, in which it is consisting of 3 arrows and 2 triangles. As the discussion said earlier, that we have two symbols of Babylonian numeral, in which it looks like an arrow and a triangle, where an arrow is equivalent to 10 and one triangle is equivalent to 1. So in this example, we have here 3 arrows, so it is equivalent to 30, and 2 triangles where it is equivalent to 2. Let's sum up these symbols, we can get the answer, which is 32. Let's move on to another example, which is example number 2. However, example number 2 is different from example number 1 because this example number 2 is consisting of group of symbols and it is separated with distance. Now, the question is how we are going to solve or convert this Babylonian numeral group of symbols into Hindu-Arabic numeral, in which Hindu-Arabic numeral is our modern number system that we are using today. It is the 0 to 9 numbers. Let's see the solution to the next slide. This is the solution for example number 2. Where example number 2 is a group of symbols and it is separated with distance. Now, you only need to do is to multiply the value of these groups by increasing power of 60. Hence, we have here the 0 group, the 1 group, and the 2 group. It means that the 0, 1, and 2 is the number or the increasing power of 60 that you are going to multiply into the group of symbols. The first group is the 0 group. We have 3 arrows and 2 triangles, and it is equivalent to 32. And we are not going to multiply it by increasing power of 60 because it is belong to 0 group. So it means there is no 60 that you are going to multiply. The second group, which is the number 1 group, in which you are going to multiply it by 60. The group symbols is equivalent to 22 because we have 2 arrows and 2 triangles. And the last group is, it is consisting of 3 triangles, in which we have so it is equivalent to number 3, and we are going to multiply it by 60 power of 2 or 3,600. So we need to multiply these values. So we have 3 times 3,600, we have 10,800. And 22 times 60, we have 1,320. And the 32 value. And the next step you need to do is to add these values. We have 10,800 plus 1,320 plus 32, and the result is 12,152. That is the process in converting Babylonian number symbols into Hindu-Arabic numerals. We have here another idea, where there is no symbol for zero in Babylonian numeral system. However, some studies said that the two slant triangles is the symbol for zero, but there is no evidence that the Babylonian used this symbol as their zero. You might wonder that we multiply those group of values a while ago with the increasing power of 60. It is because Babylonian number system is a sexagesimal numeric system in which its base is 60. Here, another idea, where Babylonian used a symbol, an arrow above a triangle, as their subtraction. As you can see in the picture, the group of symbols subtracted in this symbol, which is the arrow above a triangle. So we have 30 minus 2 is equal to 28. Let's go to another example, which is we are going to convert Hindu-Arabic numeral to Babylonian numeral. We have here three examples. First, 13,331, number 2, 855, and number 3 is 60. And now, we have here the solution for number 1. Remember the power of 60, where Babylonian numeral system is the sexagesimal numeric system. So we have 60 power of 1 is equal to 60. 60 power of 2 is equal to 3,600. It is because 60 times 60 is equal to 3,600. And we have 60 power of 3 is equal to 216,000. Step 1. You need to divide 13,331 to a power of 60. So we need to choose a power of 60 that can divide 13,331. So we choose 3,600 because it is divisible by 13,331. So 3,600 is our divisor. We can't choose 216,000. It is because it is greater than 13,331. So 3,600 times 3, we have 10,800. And we need to subtract 13,331 to 10,800. We got a result of 2,531. And the next step is we are going to divide again 2,531 to a power of 60, which is 60, where we can't choose 3,600 because it is greater than 2,531. So 60 times 42, we have 2,520. So let's subtract 2,531 to 2,520, and we have a remaining number of 11. The next thing you need to do is to get 3, 42, and 11 as our basis in creating Babylonian number symbol. We have 3 times 60 power of 2 because we multiply it 3,600, that is why 60 power of 2. And we are going to write 3 as Babylonian number symbol, which is it is consisting of 3 triangles. The next one is we have 42 times 60, where 42 is we multiply 60 to 42, that is why 60. So we have to write it into the Babylonian numeral symbol. We have 4 arrows and 2 triangles. And the last number is 11. We didn't multiply it by 60 because 11 is greater than, lesser than power of 60. So we need to write this in order. First is we are going to write the symbols that we didn't multiply a power of 60, which is 11. And the second one is the value of 42 because we multiply it by 160, only 160. And the third symbol that we are going to write is the number 3 value because we multiply it by 60 power of 2. Remember that we are going to arrange this in order or following the increasing power of 60. So we got the answer now. So as you can see in the slide, there is an answer of group of symbols represents as 13,331. We have here the solution of number 2, which is 855. It is the same process as this example number 1, So we are going to divide 855 to a power of 60, which is 60. We can't choose 3,600 because it is greater than 855. So we have 60 times 14. It is equal to 840. We need to subtract 855 to 840 and we have the remaining value, which is 15. And we can't divide 15 to another power of 60 because 15 is lesser than power of 60s. And 14 and 15 is our basis to create a Babylonian numeral symbols. We've got 14 times 60 power 1, and we are going to write 14 as 1 arrow and 4 triangles, and 15 as 1 arrow and 5 triangles. And we are going to write it in an order form to get a answer for 855. So we are going to write first the value that we didn't multiply it by 60, and the next one is a value that we multiply it by increasing power of 60. First is the value of 15 and the second is the value of 14. So we've got the answer for 855. We have here the example number 3, which is 60, the same process as the previous examples. So we're going to multiply 60 to a power of 60. We choose 60 as our divisor, and so we are going to multiply 60 times 1. We've got 60. So 60 minus 60, we've got 0. And 1 is our basis to create a Babylonian symbol. So we've got 1 times 60. So 1 here is we're going to write it by 1 triangle. So the symbol for 60 is a 1 triangle.
We conclude that Babylonian numeral system is an old system of computing a number. Mathematics is an older than civilization. Mathematics is older than civilization. It's because it's already there even before humans knew how to read and write. And also, mathematics evolved from simple measurements and counting to calculations that fueled humanity to explore the vastness of our universe. As you all might know, SpaceX, together with NASA, sent a rover named Perseverance to Mars. And what do you think helped to figure a way how to land foreign objects to the red planet? It's mathematics. And Why study the history of mathematics? The contribution of mathematics, particularly the Babylonian numeral system, has greatly affecting human lives, in which it was used for astronomy observations. It served as a pioneer in creating another mathematical principles like trigonometry and many more that can be discussed by the next reporters. Hence, it inspired us to love mathematics instead of hating it. And also, in order to understand and discover new mathematical methods, we need to study the origin of mathematics and how it evolves. These references showed where we used to gather some data. Is there any question?